Okay, let's just get right into it. The AI revolution, it isn't some far-off thing on the horizon. It is a full-blown industrial gold rush, and it is happening right now. But this isn't just about some clever software. No, this is about a physical transformation of our world, really on a scale that most of us haven't seen in our lifetimes.
And the scale, well, it's just mind-boggling. To actually power this revolution, we are looking at a global infrastructure investment that could hit $3 trillion by 2030. Let that sink in for a second. $3 trillion for the buildings, the servers, and the power grids needed to make AI a reality for everyone.
And look, this isn't just us talking. The experts are all saying the same thing. As JLL puts it, we're right in the middle of a massive investment supercycle. So in this explainer, we're going to follow the money. We're going to look at this colossal physical build-out, we'll tackle the single biggest roadblock, power, and we'll see how all of this is completely redrawing the map for markets and for jobs.
Now, you know the old saying about a gold rush, right? The real fortunes weren't always made by the folks panning for gold. They were made by the people selling the picks and shovels. And in 2026, the AI Gold Rush is all about those digital picks and shovels, the physical foundation it's all built on.
I mean, just look at the velocity of the spending. That 83% annual growth in infrastructure software, that's just wild. The entire stack, from the apps on your phone to the specialized chips that make them work, is just being flooded with an absolute tidal wave of investment.
And this right here shows you the real-world cost. We're not talking about lines of code anymore. We're talking about concrete, steel, and cooling systems. The cost to build just 1 megawatt of data center capacity, which are really the new factories of the AI age, has just gone through the roof. And that's before you even spend a single dollar on the servers to fill it.
So who's spending all this cash? Well, it's the giants, the hyperscalers. The big cloud providers are in an absolute arms race. And these numbers, they aren't just pie-in-the-sky forecasts. We're told these represent contracted deals. They are signed, sealed, and the checks are already being written to build the future.
So why? Why is this build-out so ridiculously massive? It's because we're moving past the first stage, which was just teaching the AI models. That's called training. Think of it like sending the AI to college. Now we're in the era of using them 24/7. That's called inference. Every single time you use an AI app, that's inference, and it needs a constant, always-on, massive network of data centers.
And the result of all this demand? An unbelievable space crunch. A 97% global occupancy rate means there is literally no spare room. We're talking about companies leasing entire buildings that haven't even broken ground yet. The demand is just completely outrunning our ability to build, creating this fierce competition for every single square foot of powered space on the planet. Okay, so you can have all the shiny new data centers in the world, but without electricity, they are just very, very expensive warehouses. And that brings us to the single biggest bottleneck, the one thing that could bring this entire gold rush to a screeching halt: power. This is the multi-trillion-dollar question, isn't it? AI's thirst for energy is ravenous. It's unlike anything we have ever seen before. So as we're building out this entire new digital world, how in the world are we going to keep the lights on?
Well, here's the problem. Our existing power grid just wasn't built for this kind of demand. You know, it can take over 4 years just to get a new data center connected. The infrastructure itself is aging. A lot of it is over 25 years old, and many regional grids are already stretched to their absolute limit. The new demand from AI alone, it's like trying to plug Texas and California into the national grid all at once. It is a monumental challenge.
And just to put a hard number on it, we need to add 100 gigawatts of new power capacity by 2030. To put that in perspective, that's basically what it would take to double the entire global data center footprint that exists today. It's a shocking number that really hammers home the scale of the energy problem that we absolutely have to solve.
So, with the grid totally strained and renewables like solar and wind not being able to run 24/7, where do the biggest companies in the world turn? Well, they're turning to a surprising and, let's be honest, once controversial solution. Nuclear energy is having a massive comeback, precisely because it provides that 24/7 carbon-free baseload power that a constant AI workload absolutely demands.
And hey, this isn't just a theory. The deals are already happening. Microsoft is powering a data center directly from a nuclear plant. Google is literally ordering a new generation of small reactors. And you can see the market is responding in a huge way. Stocks for reactor tech, for uranium fuel, they're all surging.
Big tech is betting big on nuclear.
Now, a huge piece of this puzzle is something called SMRs, or small modular reactors. You can think of them as the next generation of nuclear power. They're smaller, they're designed to be safer, and you can build them in a factory setting. This makes them a perfect fit to be built right alongside the massive data center campuses of the future.
So we have this massive physical build-out, and it's being held back by an energy revolution. What does all of this mean for the wider economy? Well, this section is all about how this gold rush is changing everything, from how people invest their money to the very nature of work itself. For the past couple of years, the market has been obsessed with the Magnificent Seven, the big tech companies actually building the AI models. But in 2026, a whole new way of thinking is taking over, the halo trade. Instead of betting on the AI software, investors are shifting to the companies providing the essential physical stuff, the energy, the industrial equipment, the real estate, the picks and shovels. And HALO is a great acronym. It stands for Heavy Assets with a Low Risk of Obsolescence. It's a strategy that gets that no matter which AI company wins the software race, they are all going to need electricity, copper wire, cooling systems, and buildings. These are the tangible, essential assets that are way harder to replace than a line of code.
Of course, the question on everyone's mind is jobs. Is AI coming for all of them? Well, the real story is a lot more complex than just simple replacement. The data suggests that what AI is really causing is a profound reshaping of the labor market, getting rid of some tasks, while at the exact same time creating entirely new jobs.
And this chart really visualizes that complex picture. On one hand, you see the massive global scale of the shift. 300 million jobs exposed to some automation. But then, at the same time, you see this very real, tangible job creation. Over 216,000 new construction jobs just to build these data centers. The big takeaway here is that for more than half of all US jobs, the very nature of the work is changing. It's not a simple story of job loss. It's a fundamental shift in skills across the entire economy. So why are we going through all this disruption? What's the payoff? Well, this is it. An average productivity boost of over 11% for companies that adopt AI. This is the economic engine that promises to drive growth and innovation, and if we can navigate this transition well, a higher standard of living.
And that brings us to our final section. All this infrastructure, all this power, all this investment, it's all being built for something. It's laying the foundation for the next great leap in technology, the shift from just generating things to true autonomy.
Let's talk about Agentic AI. This is where things get really interesting. If the AI we have now is about assisting you with a task, like helping you write an email, Agentic AI is about doing the entire task for you. These are systems that can plan, execute, and adapt across really complex goals, all with very little human help. This is the giant leap from a helpful co-pilot to an autonomous agent that acts on your behalf. And that really leaves us with the ultimate question. This entire $3 trillion build-out is setting the stage for a fundamental shift in our relationship with technology. As AI moves from being a tool that helps us to an agent that acts for us, what does that mean for the human role in all of this? How do we redefine work and creativity and even our own decision-making in this new age of autonomy? It is, without a doubt, the central challenge and the biggest opportunity of our time.